Hi, my name is Angelica, and I'm going to show you how to configure sensor measurements and output signals in FlexLogger. FlexLogger is configuration-based DAC software for data logging, automation, and monitoring test execution. We're going to configure vibration and tachometer measurements to understand the characteristics of our fan, as well as temperature measurements and light sensors to understand the environmental conditions of our test chamber. The last thing that we're going to configure is our output signals to control our fan speed. So let's get started. I've got the FlexLogger software open on our channel specifications tab where we configure all of our measurements. What you'll notice is that as you're configuring different measurements in FlexLogger, based on the measurement that you're using and the type of sensor that you're configuring, you're going to get different settings to convert that data into usable engineering units. The first sensor we're going to configure is our thermocouple sensor. We're going to select temperature as the physical measurement and thermocouple as the sensor class. I'm going to select the minimum and maximum that I expect at 15 degrees and 35 degrees. And I'm going to change my thermocouple type, which is going to give me different scaling. So I can confirm that I'm getting my measurements from my thermocouple, so we're all good to go. Now I'm going to copy those same settings that I had. This is going to make it really easy to scale across a large number of channels, as well as minimize the potential risk of making mistakes. So we're going to copy and then paste. The next thing that we're going to configure is the analog output to control the fan. So I'm going to configure my fan speed. And I'm going to set the physical generation to voltage. And we're going to leave that current value at 0, but I am going to enable the reset value. This is going to ensure that anytime the system shuts down or a channel gets deleted or a project is closed, especially if that happens unexpectedly, then my output gets returned to a safe state. The next thing that we're going to do is configure our vibration measurements. So we're going to select acceleration as our physical measurement and IEPE as the sensor class. Once again, I'm going to set my minimum and maximum. And in this case, since I have the dynamic sensitivity from my cal sheet, I'm just going to enter that here for my scaling. And so I can confirm just by tapping that I'm getting some vibration signals coming in. The last thing I'm going to do is enter my sensor serial number. And so similar to all of these physical and electrical settings that I've entered, FlexLogger will save the sensor properties along with our settings, so that way we have traceability into how our measurements were configured. I'm also going to adjust the sample rate. You have 3 different options of sample rates that you can set for all of your measurements within FlexLogger. So I'm going to increase the sample rate of my vibration measurements to 10K, since these are fast dynamic signals. And then I'm going to copy this channel for my Y accelerometer. Next, we're going to configure the fan speed measurements using RPM. For the physical measurement, I'm going to select the angular velocity, and we're going to do this using the frequency counter. The tachometer outputs 2 pulses per revolution, so I'm going to enter that as my scaling information and adjust my minimum and maximum output. This might be a little hard to see, but I'm going to adjust the dial on my fan so that way we can just test to make sure that we're getting the signals we expect. Great. I'm going to switch this to a different mode so that later we can actually automate this using a voltage output instead of a knob or dial. All right, the last sensor that we're going to configure is a custom light sensor. There may be some situations where you have a custom sensor that doesn't have documentation, and so you can actually use FlexLogger to calibrate the electrical values into the physical values that you would expect. Now I'm using this light sensor as a proxy for a way to determine whether, for example, the door to the test chamber is open or closed based on the amount of light that's coming in. So we're going to select custom for our physical measurement and voltage for the sensor class. And I'm going to enter lumens as my custom unit and LU as the abbreviation. Just because I'm looking for a high-level reference point, I'm going to enter a minimum and maximum from 0 to 100. Now it's time to calibrate our measurements using 2-point scaling. So for the minimum value that I would expect, I'm going to cover the sensor for when no light's coming in, and FlexLogger is going to take an average of the electrical values that it's measuring. And then I'm going to remove my hand to take an average of the electrical values from when all of the light's shining in. So now, as I move my hand in and out of the light sensor, we can see how that electrical value is changing based on the amount of light that's coming in. And so that's how you configure sensors and signals in FlexLogger.